So again, we look at this problem. A study shows that 0.9% of a population of over 4 million carries the virus. Find the smallest sample from the population so that the probability of the sample having no carriers is less than 0.4. And problem here is we're asked to find the size of the sample, so the number of trials. So it's the n that is the unknown here. And we saw that we couldn't solve this directly on the calculator, so we have to do part of this by hand. So we have our variable, which is binomially distributed with the parameters n and 0.009. And we also know that the probability that virus carriers is equal to 0. We want that to be lower than 40%. So we can start finding, we know that this probability here, we know that we can also write this in this way here. So the probability that x equals x, or our random variable is equal to a certain value, is this formula expression here. So we're going to copy that, but just put in the information that we have. So this is capital C, where n chooses x, or n chooses 0 in this case, because it's the value 0 that we're using here. But n is still n, because we don't know what n is. So this is our unknown in this case. And that's going to be multiplied with the probability to the power of 0, and then 1 minus the probability to the power of n minus 0. And this is going to be equal to 0.4. And I'm just setting it equal to now because we want to find the limit, so that the point where there are 0 carriers. Now, we can translate this bit here into what we have up here, right? So n factorial divided by r factorial and so on. And what this is going to look like now is, okay, n factorial divided by 0 factorial multiplied with n minus 0 factorial. And then we have the probability to the power of 0, which is 1. So it doesn't matter what the probability is. Anything to the power of 0 is going to be 1. And we multiply that with 1 minus 0.009. I advise you to use your calculator to find that number rather than doing it by hand. And that's going to be 0.991. And this is to the power of n minus 0, which is just n. Okay, and this is still equal to 0.4. Now, we see what happens at the left-hand side here is that, okay, 0 factorial, that's just 1. And n minus 0 factorial, that's just n factorial. So this is quite simply n factorial divided by n factorial, which is going to be 1. And then we have 0.991 to the power of n equals 0.4. So the final equation is going to be 0.991 to the power of n equals 0.4. And now we really need to graph this, and we're going to compare this graph with the probability level that we have, which is 0.4.